So we would like to move to next presentation. I'm delighted to invite Dr. Hu Jingnan to deliver his presentation. And Dr. Hu is Director of Institute of Atmospheric Environment in Chinese Research Academy of Environment Sciences, CRAES in China. Dr. Hu will deliver a presentation of study on the co-control of PM2.5 and ozone pollution in Beijing, Tianjin, Hebei, and the surrounding region of China. Dr. Hu, please, you have the floor.
Okay, thank you, Ms. Dong. Good afternoon, everyone. It's my honor to give a talk about the co-control of PM2.5 and ozone pollution in BTH plus area in China. So I will give the presentation in 3 parts. The first is the PM2.5 and ozone pollution characteristics in BTH. So actually, I would like to start with some PM2.5 and ozone formation mechanism, because at these 2 charts, we can see that the PM2.5 and ozone pollution, actually, both of them have the similar source and precursors in common. For example, the anthropogenic sources, including the industrial mobile sources, and also some heating emissions, and also from the household. And also, both of them also have some emission sources from the biogenic sources, including the vegetation. And for the pollutants, they both have the VOC, the volatile organic compounds, and the NOx, the nitrogen oxides for the precursors. And during the chemical formation of the PM2.5, especially the secondary PM and also the ozone, the ozone is not only a product of the photochemical reaction in the day, but also the ozone plays a very important role as an oxidant to oxidize the SO2, and NOx and VOC to the secondary particles, for example, the sulfate, nitrate, and also organic compounds. And in the East and Central China, also we list the PM2.5 and ozone pollution days here in this chart. So we can see that in 2020, most of the cities in red color, both exceeding the annual concentration limits of the PM2.5, which is 35 microgram per cubic meter for China, and also the ozone limit, which is 160 microgram per cubic meter for the assessment standard for China, and which both of them are regulated in our national ambient air quality standards. And most of the cities are located in Beijing, here, Tianjin, and Hebei province, and the surrounding area, including the Shandong province and the north of Henan province. So we call it BTH, Beijing, Tianjin, Hebei, and surrounding BTH plus region. And other cities in yellow colors, which means they only exceed the annual limit of PM2.5. The cities are located in the South Henan province, the Central Jiangsu province, and Anhui province, and also the Hebei here, and North Hunan province, and Liaoning province. Few cities in purple color here and here, located in the South Jiangsu, and also this is Qinhuangdao in Hebei province. They exceeded the annual limit of ozone only, and not they meet the PM2.5 standard, but exceed the ozone limit. And these slides show actually the monitoring data from the background, the regional concentration, and also the rural observation. So for the green column show the background, and actually the background values stand for the national average, because we think for the whole China, actually the national average background is the real background for the whole region. And this red column shows the regional average concentration, and also the blue columns show the monitoring data, the average of the monitoring data from the rural area, from the urban area. So we can see that there's a data in 2019. So we can see that in 2019, actually PM2.5 background level, the green column could reach around 10 microgram per cubic meter nationwide, which means we still have actually very low PM2.5 background. But the concentrations in urban here, the blue column, and also the rural size, which means the regional concentration in BTA region are much higher than the background. And also in the late autumn and winter time, for example, from the November to the next February or March, the PM pollution actually much higher than the summertime, for example, from the June to September, actually, which is much lower than the cool seasons. This is for PM2.5. But for ozone, actually, it's another story. We can see that actually for ozone, in 2019, the ozone background level, also the green column, are pretty high. It's around 80 microgram per cubic meter throughout the year. And for the whole year, actually, the ozone background level keep in a very high concentration. And even in the summertime, for example, from June to August, actually the background ozone concentrations are a little bit lower than the winter time. So which is actually different from the urban observation. And we can see that only from May to September, which is called the warm season or the ozone season, the higher ozone concentrations were observed in the urban monitoring sites, which in the blue column, and also the rural monitoring sites, which means actually stands for the regional ozone pollution. These two columns are higher than the background. Otherwise, actually in the fall and autumn season, in the fall and winter season, actually the rural and urban ozone pollution, ozone concentration actually is lower than the background. So they are quite different. And we also check some pollution episodes in this BTH region. For example, in the summer of 2021, and during a typical regional ozone pollution episode in the summertime, we can see that actually the daily PM2.5 concentration increased along with the ozone pollution in the same days and the cities. For example, we can see here, actually, which is located in Hebei, Shandong, Jiangsu, and Henan, this area. We can see that both have the ozone pollution and also not very heavy pollution for PM2.5, but also we can see the accumulated PM2.5 pollution here in the same area. But and also the two pollution occurs at the same day. But when we look at the diurnal variation of the PM2.5 and ozone, actually they are quite different. We know that in the daytime, especially in the afternoon, the ozone pollution reached the peak here, like this peaks for ozone pollution. But the PM2.5 pollution occurs the peak concentration in the night time here. And also we can see that actually the ozone as a oxidant, it will promote the production of the nitrate in the nighttime. So to increase the PM concentration. So that's the first part. And second part, I like to discuss the meteorological conditions for PM2.5 and ozone pollution. Because we know actually for both PM and PM2.5 and ozone, the meteorological conditions are play a very important role to the formation of this pollution. So we will check. We'll check the unfavorable meteorological conditions for PM2.5 and ozone. And for PM2.5, actually, the conditions for that is a low wind speed. For example, the near surface wind speed less than 2 meters per second, and also the relative humidity higher than 60%, and near surface inversion, and also the boundary layer heights less than 500 meters. So these are the major meteorological conditions unfavorable for the PM2 pollution. That means it is easy to cause accumulation of the local primary pollutants, and also to cause the chemical formation of the secondary pollutants, for example, the nitrate, sulfate, and also the organic compounds. And for the ozone pollution, actually the meteorological conditions which play the key role are different. For example, the maximum ambient temperature, the wind speed and direction, and also relative humidity and rainfall, and solar radiation and cloud cover, which play the key role to cause the ozone pollution, and it's from US EPA ozone forecasting guideline. This chart, and we also did some statistics of the ozone pollution and ozone concentration, and also with this key meteorological parameters. In BTH region, we can see that the ozone pollution is easy to occur under the meteorological conditions, including the maximum ambient temperature above 20 degrees C. In this chart, we can see that above 20 degrees C, we can see a lot of light pollution and medium pollution and also heavy pollution days here. And also the relativity humidity lower than 60% here to see these pollution days. And also a daily average wind speed, which means accumulation conditions for the precursors, including the the NOx emissions and also the VOC emissions. So the average wind speed lower than 5 meters per second here will cause the ozone pollution. And we also checked the conditions for the parameters for both PM2.5 and ozone. Actually, we saw the daily average wind speed, which for the accumulation of the emissions and pollution, and the rainfall, which have their precipitation, have the similar effects on the PM2.5 and ozone. Here we can see that when the wind speed goes larger, actually the PM2.5 and the ozone pollution days decrease. And also for the rainfall, if we have the much larger rainfall, the PM2.5 and ozone pollution will decrease. But for the temperature and for the humidity, and also for the days of the solar radiation, they have different effects on PM2.5 and ozone. For example, for the temperature, the ozone rise with the temperature goes up, but actually for PM2.5, the peak pollution actually occurs around the 0 degrees C to 5 degrees C in this area. Especially for that means in the winter, in the late fall and the winter time. And we also did some assessment for the last several years. Assessments show that actually the meteorological conditions contributed about 70% of the ozone variation in BTH region in recent years. And compared to the anthropogenic emissions, the meteorological conditions have greater effects on ozone pollution rather than the PM2.5. So it's about like actually the just in a few continuous years, consecutive years, the ozone pollution variation may be dominated by the meteorological conditions. Okay, so the last part is the pollution causes study and the control strategy. So first, I like to discuss the transport of the regional pollution, because we know the PM2.5 and ozone pollutions, both of them have a very important regional transport characteristics. So for the PM2.5 pollution in the BTH cities, they are affected by the regional transport and with an average annual contribution of around 20% to 30% for each city. So that's the annual average for each city. Is regional transport will contribute 20 to 30% of the PM2.5. But during the heavy pollution period, especially in the winter season, actually the regional transport impact will increase by about 15 to 20%. That which means the regional transport will contribute like 35 to 50% of the PM2.5 in each city. And for Beijing city, which is located here, actually the peak contribution could reach 60 to 70% from the southwest, southeast and east side. So actually, that's why we have to do the regional joint control and prevention and control for the whole region. And for the ozone pollution, actually, also the transport cannot be ignored. Actually, the ozone lifetime lasts for 1 or 2 weeks. If they don't have the chemical reaction, the lifetime is about 1 or 2 weeks, much longer than the high reactive VOC. And the ozone pollution transport to Beijing mostly occur from in the day from the 7 a.m. to 8 p.m. So it mostly occurred during the day for the transport of ozone pollution. This shows from the modeling simulation. And also Hebei and the Shandong province actually are the largest 2 contributors of the ozone pollution transport to Beijing. And talking about the ozone pollution, we cannot forget the vertical transport because actually in the current study revealed that actually the vertical transport under the boundary layer contribute about 20 to 50% of the surface ozone. So what we observed at the surface monitoring station, the ozone actually during the day, it may come from the pollution from above the surface. So, but how to quantify the contribution is still a challenge. And we can see the diurnal variation of the ozone at different height. For example, this is shown a monitoring observation in Shijiazhuang city in Hebei province, the capital of Hebei province. We can see that the green dots show the midday, which means the noon data, and also the red dots show the morning data. So we can see that actually at the different height, the ozone concentration at different height actually they vary at a very different way. So that which means if we just check the observation data at the surface, so it's quite different from the higher level. So we cannot forget the vertical transport. And talking about the anthropogenic emissions in BTH region, this show the emissions in BTH region actually is still large, and the emission intensity is about 3 to 5 times higher than the national average for different pollutants. For example, the SO2, NOx, PM2.5, and the VOC. And the higher VOC and NOx emissions intensity per unit area are observed in Tianjin city here. This is Tianjin city, and just close neighbor to Beijing. And the Tangshan city here in Hebei province. And the Jingnan city, the capital of Shandong province here. And the Zhengzhou city in Henan province here. So which means we have to control these precursors emissions at a higher level. And besides the anthropogenic emissions, we cannot forget the biogenic emissions of VOC in this region. So we also see larger VOC emissions in the summertime, especially in the hot days with high solar radiation, which means the cloudless days have a higher the biogenic emission, VOC emissions. This is example in just in the last month, in June of 2022, when my colleagues did the simulation and shows the larger biogenic emissions in this region compared to that in May, and also which also contributed to a higher ozone pollution in this area. And we collect some literary study data, and the study shows that the PAMs, the photochemical assessment and monitoring data, actually show the concentrations in typical cities in China are higher than those in the US cities. For example, the Houston, the Washington, DC, and San Francisco, and Los Angeles cities, and especially for the alkenes and aromatics here. So we can see that for the US cities in the 1980s, 1990s to 2005, and also in the last decade in Los Angeles, they have a lower alkenes, the blue color, and also the green, and the aromatic, the blue parts. So they have a lower, not only lower the PAM's concentration, but also the lower fraction of the alkenes and aromatics compared to the typical cities in China. So which means it's still a long way to go. And finally, I want to show a modeling simulation from Tsinghua University, Professor Wang's group. Their simulation indicate that the VOC emissions along with the NOx emissions are the two key pollutants to control for during the coming 10 years. We may have these two key pollutants to control at the first stage, and in the further step, we may to have a further NOx emission control for this area to cut the emissions, and also to reduce to mitigate the PM2.5 and ozone pollution both. Okay, so that's my talk. Thank you very much for your attention.
Thank you so much, Dr. Hu, for make a very substantial analysis from your presentation. We could have more understanding on the overview of the BTH area, which is one of the most important areas in China. And your analysis is from some different aspects, including the seasonal and also the episode analysis. And also at the later part of Dr. Hu's presentation, you also shared some recent studies on the vertical transport of ozones as well as the BVOCs. I guess we have some scientists and experts specifically in the atmospheric photochemical studies, and also the ozone expert like Ahmed Sensei. So maybe the later on discussion, we could share a little bit of the comments on your presentation.